Right, Assalamualaikum and good morning. Okay, today I will discuss the post lab and the calculation for experiment 3, that is the determination of the molar mass of a metal. Okay, now let's have a look at the first part. There are two parts, right? Part A and part B. Okay, let's start with part A. In part A, you need to determine the concentration of hydrochloric acid. So what I have here is the sample, yeah, only sample readings for part A. You have your readings, yeah. So this is just example, right? Now, first, make sure the readings are all in two decimal places and the last number is either 5 or 0. This is very important for your practical test as well. Yeah, if you have the right number of decimal places and the right numbers, then your marks, you will be rewarded marks. Yeah, if not, marks will be deducted. Okay, then look at my initial reading. It is always lower than the final. Remember, in your burette, we start with 0 on top, and as we go along, the final reading is 50. So don't go the other way around. Now, first, from this experiment, we have gross reading. Remember, gross is not counted. Yeah, we only consider set 1, set 2, and set 3, and you must show this calculation. Yeah, if not, you will short of 1 mark. And then, okay, show the average volume of NaOH and the unit must be there, that is in milliliter or centimeter cube. Right. Now, let's proceed with the calculation. We have, yeah, in this part, the average volume just now was 25.20. Okay. From the given value of NaOH, what do we know about NaOH? NaOH, the molarity was 1.0 and my average volume, yeah, sorry, my average volume was 25.20 milliliter. So what I can do now is I can calculate the number of mole of NaOH. Okay, the formula is just like before, molarity times volume. And if you do this calculation, remember the volume is in liter. And in my case, I will get 25.20 times 10 to the power of negative 3 mole. But we want to calculate the molarity of HCl. So, 1 mole of NaOH reacts with 1 mole of HCl. And if you calculate, you will get the number of mole of NaOH to be the same as HCl because the ratio is 1 to 1. Okay, right? So are you with me? I hope you can follow my calculation. Right. So in this case, we have NaCl to be 25.20 and okay, similarly, it equals to M times V. And now we can calculate the molarity of HCl. Why do we need this molarity? Because this molarity will be used, yeah, the same HCl will be used in part B. And if I substitute my volume here, what was the volume of HCl in the titration? 25 ml, correct, in the conical France, right? And in my case, my molarity, I will get 1.008 molar. Remember, to be recorded to at least 3 significant figures, better if you have 4. Okay, and this one is alternative. Or you can use this relation, which is MAVA over MBVB, and the mole ratio is 1 to 1. Okay, you must use MAVA, or you can put MHCl, VHCl, and so on. Don't put M1V1, yeah, be more specific. So in this case, we don't know the molarity of acid, but we know the volume, 25 times 10 to the power of negative 3 liters over molarity of base 1.0 molar times 25 point, sorry, yes, 25.2, yeah, in my case, times 10 to the power of negative 3 liters, and the ratio is 1 over 1. And you can solve for molarity of acid. You should get the same value, 1.008 molar. Alright, so that is our molarity determined in part A. Now, we shall use the molarity. Okay, now I'm putting the molarity of HCl here, so that we we remember, yeah, to be used in this calculation. Okay, remember, yeah, in part B, you want to determine the molar mass of unknown metal. What did you do the other day? First, you have how much of HCl? 25 mil, right? 25 mil of HCl. Okay, so, and the molarity was 1.008 molar. This is my molarity. Yeah? You should calculate your own. So from this value, we can calculate the NHCl initial. Yeah, initially, how much HCl do we have? M times V, and it is just 25 times 10 to the power of negative 3 liters multiplied by 1.008 molar. And in this case, yeah, my case, I should get 0.0252 mole. Okay, now, okay, what happens next? Okay, when you put in the metal, unknown metal, the metal will react, yeah, with the HCl. But we only used a small piece of metal. Therefore, not all, yeah, not all HCl will react. The metal will only react with a small amount of HCl. Therefore, we still have HCl left. That means we have HCl in excess. Yeah, the one unreacted. It is the unreacted HCl. Yeah, which is that was titrated with NaOH. Yeah. So in this case, we have HCl plus NaOH. Which HCl? The one in excess. Reacts with NaOH to give you the same products, NaCl plus H2O. Alright, now, what do we know about this HCl? Yes, we know the um, molarity. Yeah, we know the molarity. What do we know by NaOH? Yes, we know the volume and we know the molarity. So we can calculate the number of mole of NaOH reacted. Okay, in my case, my volume was 17.8 milliliters. So it's just M times V, yeah? M times V times molarity, 1.0 molar, and you will get, in this case, 0.0178 mole. Yeah, just the same number. So from NaOH, we can calculate the number of mole of HCl. 1 mole of NaOH reacts with 1 mole of HCl. So if we have 0.0178 mole of NaOH, that will give you the same amount of HCl. So this is the HCl in excess. Right. Knowing the one initial, yeah, initial, and the one in excess, yeah, sorry, this is NHCl in excess. That means now we can calculate the amount of HCl reacted with metal M. Yeah? Okay, let's proceed. So NHCl initial, the total, the total that we start with equals to the NHCl reacted plus NHCl unreacted. Unreacted means the one in excess. So we substitute the values. 0.0252 mole equals to, this is the one that we want, reacted, plus 0.0, oops, sorry, 0.178 mole. And now you can get the value of HCl reacted. In this case, my value is 0.00740 mole. Now, so from the given equation in your lab manual, M plus HCl gives you MCl2 plus H2. And if we balance this equation, it will be 2HCl. Right. So 1 mole of M reacts with 2 moles of HCl, and our HCl just now was 0.00740, and you can get the number of mole of M. If you calculate, the number of mole of M will be 0.00370 mole. Yeah? And for my sample 1, my mass stated just now, my mass was 0.0950. Okay, if we know the number of mole, how can we relate to the molar mass? We know that N of M equals to mass over molar mass. Therefore, N is 0.00370 mole equals to the mass, which is 0.0950 gram. And now we can calculate the molar mass. And when I calculate my molar mass, okay, the molar mass of M in this case is 25.67 gram per mole. All right. So this is um, the answer, yeah, for sample 1. And you need to repeat for sample 2. Okay, from my value here, I can say that, okay, I check the predict table, and this molar mass is very close to the molar mass of magnesium. When magnesium, the molar mass is 24. So I can conclude that my unknown metal is M. Sorry, my unknown metal is magnesium. Okay, right? So you repeat for part 2, repeat for sample 2, sample 2. Then from the 2 molar masses, you decide which is the closest to the theoretical value, and you take that value, yeah, when you do your discussion and your conclusion.